In this video, we're going to be proving the following identity, where if you multiply two complex numbers and take the modulus of them, it is equal to taking the modulus of each one and multiplying them by each other. Now remember that the modulus of a complex number, so we'll say z is equal to a plus bi. The modulus of z is defined to be a squared plus b squared, all square rooted. Cool. So let's first figure out the left-hand side and see what we can simplify that to. So we'll let z equal a plus bi, and we'll let w equal c plus di. Okay, so z times w modulus is equal to a plus bi multiplied by c plus di, all modulus. Now this is equal, so if we expand this, we get ac, add bci, add ADI, and then these two will make minus BD, because I squared is minus 1. So we take the modulus of this. This is AC minus BD, add AD plus BC I. Now if we take the definition of the modulus, this is equal to AC minus BD squared plus AD plus AD plus BC squared, all square rooted. So we can expand that out. So this is square root a squared c squared minus 2 ac bd plus b squared d squared plus a squared d squared plus 2 AD BC plus b squared c squared. Okay, so now in this separate box here, and so notice here that these terms will cancel out, the plus minus 2 AD BC. And so now if we work out z modulus, w modulus, this is going to be a squared plus b squared multiplied, so square root a squared plus b squared multiplied by square root c squared plus d squared. Now you can put that all under the one square root, so that's a squared plus b squared times c squared plus d squared. So this is square root a squared c squared add b squared c squared add a squared d squared add b squared d squared, which is the same thing as what we have here, a squared c squared, a squared c squared, b squared d squared, b squared d squared, a squared d squared, a squared d squared, and b squared c squared, b squared c squared. And so that is that. Thank you for watching. Any questions, please leave them in the comments below.